I built this cordwood cottage in 2020 with cottonwood that was down here on this property when we arrived. And it was a fascinating process. I learned a great deal. I've been sitting on some video footage of the build and been waiting for an opportunity to get it all edited together for YouTube. So that moment has arrived, and we'll go through the process that I used to build these cordwood walls. This structure is a timber frame that carries the load to the foundation, and the cordwood acts as an infill within the timber frame structure. You can build this way using the cordwood structurally to bear the load of the roof. That is not the case, however, in this build. So check it out and see what you think. Cordwood construction is a method of using logs in combination with a variety of mortar possibilities to build a wall for the exterior of a home that is both thermally massive and insulative. So inside of these walls, the logs are placed on a bead of mortar that is inside the wall. There's another bead of mortar on the outside. In the middle, there's a void that is filled with sawdust that is tossed with dry hydrolyzed lime powder, and that prevents mice and insects and things like that from wanting to make a home in the middle of your wall, because there is a thermal break between the mortar beds that prevents the heat from inside of the building from conducting to the outside of the building through a solid thermal mass. Like if the mortar went all the way through the wall, then as this heated up, it would conduct moisture to the conduct heat to the outside. And so this technique is advantageous in many ways. On this particular site, I have an abundance of this cottonwood, and there are places where trees have fallen and there are limbs that are suspended above the ground, so they're not rotting and they're not full of fungus that's going to deteriorate the body of the wood. And so it's an abundant building material that I can use in this particular setting. So the kind of wood that you want to use for this is typically a softwood, because it's more insulative than hardwoods. In other words, pines, spruce, coniferous species tend to be less dense than oaks, elms, apples, things like that. And so the softer the wood, the more insulative it is. In this particular situation, I have a lot of this, and so it made sense to use it in this situation. For the mortar, in these walls, I'm using a lime-based mortar, which is lime putty, which I'll show you how to make here in a moment, and sand. And that will set up harder and harder over time as this lime tries to turn back into limestone. The chemistry that's going on here, you take limestone, you put it in a kiln, you heat it up, you drive off carbon dioxide, and it takes on hydrogen. And then when you rehydrate it with water and then expose it to air again, it will reabsorb that CO2 and turn back into a rock. The advantages of using this sort of mortar instead of a Portland cement based mortar in this application are that it tends to be self-healing, and there's going to be a variety in the movement between wood and the mortar as it heats and cools, and the lime tends to be a little bit more capable of self-healing small cracks and fissures than, say, the Portland-based mortar that I used in the stone wall over here. So it's has a slower setting time than a Portland-based product, which allows you to work it in between the logs and tool it and point your joints and do all those sorts of things without it setting up on you too quickly. And it's also very affordable. It has a lower energy footprint than Portland cement. Extremely high temperatures are necessary to create Portland cement, which is not necessarily the case for a lime-based mortar, relatively speaking. So it made sense here. The advantages of it are, of course, the beauty. It's really nice to look at. The fact that it satisfies those two most important considerations in energy efficient building, where you have both thermal mass of the stone product that is going to hold and radiate heat over time, and the insulative value of the wood. So though these walls are not ridiculously insulative, they, at the 9-inch thickness that I'm setting them, should have about an R12 insulative rating. And so if you wanted to have a higher insulative value in a cordwood wall, you would want to go at 2 feet, 16 inches, something like that. Because this is a small building that's going to have a wood stove in it, it's not going to take a whole lot to heat it and keep it warm, and this should be sufficient. Code in most places is R15 for exterior walls, so it's approaching that, and it will certainly be sufficient for our purposes here. So in this video, I'm going to show you how I mix the lime mortar, and then how I mix the lime putty, and then how I mix the lime mortar, and how I set the wall, how I mix the sawdust and lime for the insulative layer, and some of the finer points of how I'm learning to make these walls look reasonably good, at any rate. So I hope you enjoy it, and feel free to ask questions in the comments below, and I will have some links down there to some of the equipment that I'm using that will make this process much more efficient and enjoyable. So we're going to make 6 buckets of lime putty. It's just water and lime mixed to a soft cream cheese consistency. Some safety considerations. This lime is rather caustic. If you get it on your skin, wash it off soap and water, you don't want to get it in your eyes. You can always, of course, counteract the alkalinity of that by adding acidity. So if you want to pour vinegar in your eyes, that's up to you. But I recommend that you use eye protection, a dust mask of some sort, and rubber gloves when you're handling this stuff. It's not something that I'm particularly concerned about in terms of safety, but I handle mortars and things like that quite a bit. So just for being on the safe side, go ahead and get all your protective gear on, and then you can work with it without having to be too concerned about which way the wind's blowing and dust and all of that, just for good measure. Bowls that we'll be using, we have our buckets. I put 1/3 of a bucket of water in each one. Grain scoop, transfer the lime, a trowel to clean the sides, rubber gloves. I have this 2-handed mortar mixer right here, and that's pretty much it. We'll get to filling these and mixing them up, and I'll show you what it looks like. Here's our lime putty. See, it's pretty soft, but it does stand up on its own. What we want to do is take the handle and gently, so it doesn't glop up on you, give it the old tappa. Clean down our sides. Get this surface nice and flat like that, and then we put a layer of water on the top. So the water is going to prevent the reaction occurring between the carbon dioxide in the air and the lime putty. And as long as this is kept away from the air, it will remain putty and be ready to use. You need to do this at least 48 hours before you intend to use it, so it has the opportunity to slake. Now, if you allow this to dry out and the water to evaporate, the lime putty will quickly turn into limestone, and that looks like this. Here is the bottom of a bucket of lime that I ignored and it dried out, and basically it's turning back into limestone. So we have our lime putty slaking, and as I say, you want to let that slake for at least 48 hours so that everything gets evenly hydrated and everything is ready to go. While we're waiting for that, we'll start preparing our log rounds. Now, I like to have a variety from small diameters up to foot or larger diameters, and then some split sections, and having that variety of pieces allows you to keep tighter grout joints. As you build your wall, you can come to a spot you just need a little piece that would otherwise be a large grout joint. So I pull a bunch of different sizes out of the forest, carry them over here, and then get to cutting them into 9-inch lengths. So whatever the thickness of your wall, 9, 16, 24, 48, however you want to build it, you'll cut them to that length. I have made a very simple square out of 2x6 drops that is 9 inches from one edge to the outside edge. And so what I'll do is I'll put this face flat against the edge that's cut, and then I'll make a couple of marks, and those two will be the reference points that will allow me to cut another surface that is roughly parallel to this surface. Every log is going to have some curvature to it, and so if you see that you're getting out of squareness to the edge of the log, you can square it up, cut off a little disc like so, and begin again. Before I begin cutting the links, I'll knock off all of the nubs and branches that are sticking out, because those are going to interfere with your ability to have tight grout joints and just make setting it more difficult. So I like to work low here, and I'm running a MS 180 still for this, which is a very lightweight yet powerful for the size gas chainsaw, and that lightweight saw allows me to work on my knees and not be bending over and bending over and picking things up and that sort of thing, so it keeps my back from getting too tired while I do this. And so I'll go ahead and knock all the limbs off of this, and then we'll get to bucket them up, and then we'll move on to how the mortar is mixed. make some this mortar, this lime mortar. The recipe is 5 parts sand, 1 part lime putty. I've got some putty that's been slaking for about 3 weeks. 48 hours is sufficient, but it can sit there for months, years even, as long as there's a coat of water on top. And if you put a lid on top of it, that'll keep the water in there. It'll last pretty much indefinitely. So I'm going to use this 4 cubic foot mixer. I'll put a link in the description where you can buy this off of Amazon for less than 300 bucks. And so this makes the process a lot easier than mixing in a wheelbarrow, that sort of thing. I'll get the inside of the mixer wet with water so that things don't want to stick to it. I'll put 2.5 5-gallon buckets of sand in there, and then I will take the trowel and I'll huck half a bucket of lime putty into it, and then add water until I reach a consistency where it's not too crumbly. And if I can make a ball out of it, throw it up in the air, and then catch it, it'll just flatten out slightly. And that's your target consistency. It's pretty forgiving, and you'll see what it looks like and then have a pretty good idea how to go from there. The mortar into 5-gallon buckets, and because this is nothing but lime putty and sand, we can make this well ahead of time and cover it with water, and it will be ready for us when we're ready for it. Unlike a Portland cement mortar, which once you add water, that reaction has begun, this one, as long as it's kept out of contact with air, will remain pliable and usable. So I fill all these buckets up, get them leveled off, and just add 1 inch of water, and that's all it takes. One more step before we can start building our wall is to prepare the sawdust insulation. Basically what we're doing here, laying in about 1.5 inches high by 3-inch bed of mortar. Doesn't have to be anything precise. So I'm going to my inside line and then to the edge of my form, and I'm leaving a void in between them. And we'll do the entire that we're going to set, and then add a little bit of our sawdust insulation and start putting logs. In my circumstances, when I started building this building, cordwood was an appropriate choice due to the fact that I had a great amount of cottonwood that had fallen over but had limbs that were up off the ground and not rotting, that it had an opportunity to dry out for a very long time before I cut it for this purpose. If you wanted to build a cordwood building and did not have a resource like that, but you did have some sort of timber that you could use, you would really want to fell all of that timber, peel it, and cut it up into the appropriate size pieces, and then allow it to season for at least a year so that you wouldn't end up having a great deal of shrinkage of the logs that would expose gaps between the log and the mortar joint and give you excessive drafting. These have held up pretty well, and I doubt that I would ever do another full building with this technique, mostly because it's time consuming. So like this section of wall right here took me 4 days, and so that's just from the window there to the corner, and so there's a lot involved with the time it requires to build this way. It's beautiful, it's inexpensive. If you do your walls thicker than the 9 inches I did, or you're at 16 inches or 2 feet or so, then you're going to get even better thermal performance than this building has. It's not fantastic, but it's certainly better than a tent and probably better than a lot of conventional stick frame homes. So it worked out pretty well, but if you are looking for a good natural building solution, once again, the most important thing is that you select something that is appropriate to the site, the materials and resources that you have. And once again, if you have any questions, feel free to reach out in the comments, and I'll do my best to answer all of your queries.